Yes, that was a good one, Ilya. So um, here we go. And today we will make it better. So again, going back, what were we talking about? We were talking about series, which is an infinite sum. So it is a sum of what? A sum of some terms from 1 to infinity. So it's a1 plus a2 plus a3, and so on and so forth. Please remember what we want to do. We want to find out if this infinite sum converges, meaning what? It adds up to a finite, adds up to something finite. Remember how I write something finite now because it can add up to a function as well, or it diverges. Of course, if it converges and it adds up to something, I want to know what it adds up to, whether it be a function or a number. If it diverges, then yes, I have classified it and I'm not interested. So this is what we wanted to do. And we went through a series of tests. And so you have many tests that could answer this question, whether it converges or diverges. So we have come there. But then we have discovered something new. And what did we discover? And that was so important last time. So last time, what did we discover? That we said, if you have a series, I goes from 1 to infinity, if you have this series, then one idea was take its absolute values. Which is summation I equals 1 to infinity. If this converges, the series converges. I can't emphasize to you the importance of this one, and you will see why. So here it goes. So it says a series is called absolutely convergent. I'm going to highlight this word, absolutely. You can also think of it as colloquially, but remember what we are saying. When we are saying absolutely convergent, we are saying absolute values. So mathematically, we are talking about absolute values. So series is absolutely convergent if the series of absolute values converges. But more importantly, and because of that, I'm changing the color. But here is the one that if this is absolutely convergent, then it converges. That's it. So I think I'm going to quickly go to my flow chart from last time, which was this. So you are given a series and goes from 1 to infinity. So what do? Oh, you consider its absolute values. I want to emphasize when it's absolute values, these are all positive terms. So right now, and I'm going to change that in a minute. So right now, you have many tests to determine whether this series converges. So what could happen? Oh, if it converges, then you're done. Sigma an converges. If the test sort of fails you, or I'm just going to say if it diverges, then you are going to look for the original series. And now when you look at the original series, if you get convergence, when I say original series, I'm just going to mean or say it is without those absolute values. As is. this converges, then you have got conditional convergence. If this diverges, then it diverges. And sigma an just diverges because you looked at all kinds of things. You looked at the absolute values. You looked at as it was, and it just diverges. So we did this flowchart sort of last time. So I am going to say, because we found this result, then there must be an easier way. There must be some way to determine this absolute convergence. Because remember, if it converges in absolute values, I'm done. So to determine the absolute convergence, and yes, there is.
Flipping a coin?
Literally like that, Russell. You're going to love this test, and people do. So it is the ratio test and the root test. So before I tell you what they are, I will want you to say that especially if your series has factorials, literally that, in them, then ratio test works beautifully well. Meaning none of the other tests you can work with the factorials, but this one works beautifully well. Root test, if you have nth power, and I'll give you examples of all of these. So what are these two tests? So again, remember, they are here to determine absolute convergence. So the idea is, and I'm going to draw a line right in between, that for the ratio test, remember the words ratio, remember the words absolute. So you take limit as n approaches infinity, the absolute value of an plus 1 over an. Here, you take limit n approaches infinity. Remember the word root and remember the word absolute. So you take nth root of absolute value of an. Do you want me to pause is the question at this point? Or we are okay?
No, I think we're fine.
Okay, great. So you compute the limit. And here we go. For both of them, it's the same. So if this limit, both of these, is less than 1, I think your book writes it, and I just want to write it the way your book writes it. Yeah, it says if this limit is L, and if this limit is L. If L is less than 1, then we are done, people. Then the series is absolutely convergent. And now I'm going to ask you to think of this absolutely, this word in colloquial sense, that it is absolutely convergent. It's done. It's sigma an is convergent. So the series is absolutely convergent and therefore convergent. So sigma an converges. And this is why I said, Russell, that you will like it. If L is greater than 1, then the series diverges. This is the only test which gives you both the results at one time, one test, and it tells you if it converges, diverges. But then she smiles, yeah? We can never forget that she smiles. That if L is equal to 1, you can't say anything. It's inconclusive. And so at some point, I'm going to show you why that happens. But more importantly, latch onto this one because you are going to use a ratio test and root test. And that's going to come in the next half of the class today. Determine something called the radius of convergence, which you have seen actually, the interval of convergence. Take it from me. Whoever makes this exam, the department or whoever, you are going to have a question about this because this is the most important concept. This is where we are going now, finishing the circle back towards the series, writing functions as a series and back towards integration, really. So ready for an example? So I just want to get an example and I just want to show you how wonderful this one is. Let's get a very, very simple example, and especially the one that proves my point. So ready for the example? Nothing? Nothing to talk about? We okay?
Well, there's plenty to talk about, but I think as far as math goes, we're ready to move on.
Okay, let's do that then. So this is negative 3 to the n over 2n plus 1 factorial. Now I'm going to work this very, very carefully, meaning if you kind of follow this, you should be okay. At least that is what I like to do. And as I do that, I'm going to write what I'm doing. So we are going to write it out. 3 to the 0. This is going to be 1 factorial, negative 3 to the 1. This is going to be 5 factorial plus negative 3 to the squared. This is going to be what? 11 factorial, and so on and so forth. So yes, a quick observation, this seems like an alternating series. Then why am I using the ratio test? Well, I'm using the ratio test because I do not know how to sort of deal with this one, which is what we wanted to show, that this was decreasing sequence, isn't it? So I don't know how to take the derivative of the factorial and show you it's decreasing sequence. The other thing about the ratio test is if it diverges, I can tell you that as well. Because if the alternating series test fails, or the limit of this one is not 0, or something happens there, then I have to go to the test of divergence. So I'm just going to say, oh, I see factorials. And so maybe ratio test. The other thing about the ratio test, if it converges, if I get converges here, then the series converges and I'm done. And so I'm just going to use this one. Then your question should be, why did we study the others? You're going to see why we studied the others. So here we go. So we're going to take limit as n approaches infinity, the absolute value of an plus 1 over am. Remember, it is a test to determine the absolute convergence. So this is going to be limit n approaches infinity. Now this is what I want to say to you. So I'm going to write it here, and then I'm going to write it down there. So an plus 1 would be what? And I go back and say this, that this is your an. So an plus 1 will be what? All n here needs to be replaced by n plus 1. So if I do that, then I get negative 3 to the n plus 1. Just observe this right now, write it later. This is going to be 2 times n plus 1 factorial over negative 3 to the n over 2n plus 1 factorial, which I understand that because this is division, I'm going to flip this and write it upside down here and change it to multiplication, meaning I am going to do this step in my head every single time. So I'm going to write this. If you have any questions, just stop me and ask. So this is going to be that. This one, I'm going to take care of it. This is going to be 2n plus 3 factorial times 2n plus 1 factorial over negative 3 to the n. So far, so good? Questions there? If you work like this, I assure you, you will fall in love with the ratio test.
I'm just trying to look at the 2n plus 1 plus 1.
Right, so this was an, right, Russell? So an plus 1 would be, I did that again. Yeah, so an plus 1 would be n replaced by n plus 1. So this is 2n plus 2 plus 1, which is 2n plus 3.
Got it.
And now, I don't see any questions, so here we go. This is what I do. Collect all the like terms together. You don't have to do it this way. It's just that I like to be. And what do I mean by that? I write negative 3 to the n plus 1 over negative 3 to the n, because it's all multiplied, you see. 2n plus 1 factorial and 2n plus 3 factorial. Now I want you to stop writing, all of you, And I want you to just observe, because this is what I'm going to do. So here, this part, I'm going to write this as negative 3 to the n times negative 3. Are we okay? And what did I use there? And I'm going to say this looks like this because a to the m plus n is a to the m times a to the n. We okay then?
Yep.
Very good. And here I'm going to take care of the factorials because we are what? 2n plus 3 floor. So we go one down, which is 2n plus 2. We go one more down, which is 2n plus 1. And that's it. And that's how I'm going to write this. So this is going to be 2n plus 1 factorial times 2n plus 3 times 2n plus 2. And of course, the absolute value. So what happens? Of course, this gets cancelled. This gets cancelled. And I'm left to find limit as n approaches infinity of negative 3 times 1 over 2n plus 3, 2n plus 2. And can you tell me what this limit would be?
0.
Very good. So this limit is 0, which is less than 1. So what can you say? Oh, it is absolutely convergent. ABS is absolutely, CGT is convergent. So the series converges. So this series, negative 3 to the n, converges. That's it.
Do you have to do the, I don't want to say extra steps, but the messing with factorial on the bottom and whatnot in the previous step?
No, because you took care of the factorials, remember, when you did the ratio test? You came to, see, here is what you did. If you have to look at the idea of it, Russell, then you said that I'm going to look at the ratio of what happens when I take the next term over the previous term as n approaches infinity. And I want all of you to listen in because this is the conceptual part of it. So if you start thinking conceptually, if this limit is 0, Russell, what does that mean? If this is 0, then this is bottom heavy, isn't it?
Right.
So if it is bottom heavy, then what do we have? We have an plus 1 is less than an. So it is a decreasing sequence.
Right.
And if you have a decreasing sequence and eventually that you are saying that this is going to be 0, the ratio of these two is going to be 0, then somewhere it has to converge. Because the next term that appears after this one is always decreasing. You're going down. So if you are going down and you're going down ultimately to 0, then of course it has to converge. This is just a quick way of looking at it. And the other thing you have to notice is you threw that alternating condition away. You are just looking at all positive terms. So you are saying the absolute values, and that's the most important part here. So somewhere you're going to your comparison and limit comparison in that sense.
Got it. I was actually just referring to the step limit n to infinity where you rewrote 2n plus 1 over 2n plus 3. Did you need to do that, or could you have just taken the limit?
No, you needed to do that because, you know, this is that 2n plus 3 factorial it was there, isn't it? So you are using the fact that n factorial is n times n minus 1 factorial to simplify the factorials themselves.
Got it.
So let's do one more example. And here we go. Which one did I want to do? So let's see if we can do this one. summation n equals 1 to infinity n factorial over 100 to the n. We will never shy from writing it out. So we have, So we have 1 factorial over 100 plus 2 factorial over 100 squared plus 3 factorial over 100 cubed, and so on and so forth. So again, why ratio test? Because ratio test tells me convergence, divergence, and yes, it's going to fail for us, and I'm going to show you when it's going to fail, and then what do you do if it fails, and so on and so forth. But let's attack this one first. So I'm going to take limit as n approaches infinity, and now I'm going to write it without giving you any sort of explanation, and tell me if that makes sense.
Well, first I have a question about the test itself, which is,
Sure.
Is it only for factorials?
No, I
All right.
can do one without factorials as well. It doesn't matter. It's for anything.
Got it.
But the key conceptual part is if a series converges in its absolute values, then it converges. And if you look at the notes from last time, we went over an example where it is true that if a series converges in its absolute values, it converges, yeah. So I'm going to do the next step that I wrote up there, which is collecting all the terms together. So I like to do this, which is n plus 1 factorial over n factorial, 100 to the n over 100 to the n plus 1. Now I'm going to use my eraser and do the thing that I do, which is this is times 100. This is going to be n plus 1 times n factorial. I think I should circle those. So these are the changes that I made. This is where I simplified. I don't see any questions, so it seems you're okay. So we are going to do that. We're going to cancel that. So now I'm talking about limit n approaches infinity of n plus 1 times 1 over 100. And what is this limit going to be?
Infinity?
Very good, sir. So this is infinity. This is greater than 1. So the series diverges. So now it's very, very important to see why this test is so good, that why does it fail? So Joshua, remember the Trump Tower. So if you are talking about n plus 1 factorial, Joshua, I want you to imagine you are at the n plus 1 first floor in Trump Tower. You take that elevator, so it goes to n, then it will go to n minus 1, then it will go to n minus 2. Finally, it will get you to the lobby. Those are factorials. So I can write this n plus 1 factorial, which was all these things multiplied, as just this term times n factorial. Joshua, did that do for you? Yeah. Remember, factorials, Trump Tower, we go from there. We will use anybody, Joshua, in this class to make us understand or remember math. From Brad Pitt to Trump, everybody is fair game. Okay, so the next thing that I wanted to see, I understand this test and agree. This is democracy in its. So agree with me. This is a good test, isn't it? It's simpler than all the others. I just have to compute the limit. I just have to take the ratio of an plus 1 over an, and it tells me everything. So this is beautiful. You're really, really liking it now. You really, really think the lady in the story, she was pretty. She was beautiful. Now she's going to smile. Here we go. So I'm going to, and I want you to completely stop writing that. What about this series? Converges or diverges? Very good, Joshua. Diverges because it's the harmonic series. Or you can say P series. Well, what about this one? Converges or diverges? Very good, Joshua. Converges. So you already know this. So I'm going to apply the ratio test to this one. If I do, then you know what I get. And the limiting value of this one is, you're going to fill that for me, and then say if I apply the ratio test to this one, then I get which I can take the absolute value out now because it is squared anyway. So I get so tell me the limiting value of these two. What is the limiting value of these two? Very good. So both of them, the limiting value is 1. And why does the test fail you then? Because the limiting value is 1 and this one converges. The limiting value is 1, but you know this one diverges. So the ratio test, when the limiting value turns out to be exactly 1, and I'm going to go back up there, it is inconclusive because it can point you in 2 different directions. But if the limiting value is less than 1, then no doubt about it, it converges. If it is greater than 1, then the series diverges. I want you to understand that when the limiting value is greater than 1, it is back to your comparison test. So again, stop writing and work with me. All I'm saying is if an plus 1 over an is greater than 1, which is what? An plus 1 is 3 times an. Then this one is always going to be greater than that one. And you can go back to the comparison test where we had Bn here and sort of look up from that vantage point of view. And that is what it will make sense to you, why less than 1 it converges and greater than 1 it diverges. The way I like to look at it is this is top heavy. So if this is top heavy, the limit is going to be greater than 1, that means what? Always the ratio is going to be some larger number. That means you're always going to be the next term that you add in that one. And remember, we're talking about absolute value. It's going to be 3 times the first one you added. No wonder it's going to diverge. Are we okay then?
Yep.
No questions? So here we go then. This is the beauty of that one. I'm just going to erase this fluff there. And is that for all of you? So I'm just going to start calling people out. So Aaron, you will have something to say. Jezebel, Cecily, Nara, everybody's okay? Oh, thank you. So here we are. Okay. So let's look at the next one that I said up there. What do we mean by interval of convergence and radius of convergence? Oh, recall, and I did this last time. So recall, you already know of a series. You know of a series, this one, which I can write as what? What do we know? And you already know this, so just observe. We know this is a geometric series. So we know this converges for absolute value of x is less than 1. And now I'm going to start drawing pictures. What do we mean by absolute value of x less than 1? Oh, algebraically, it means that. It means that. So you are saying that this is a geometric series, converges when absolute value is less than 1, Not only that, you are saying it adds to 1 over 1 minus x. When what? When x is between this one. So when you have a series written like that, it is called a power series. I'm going to write definition. Right now, just follow the thing because I'm trying to get to something else. This is a power series which is centered at 0. So if it is centered at 0, and you are saying that this converges when x is between in this interval. So if this is the center, then can you tell me what would be the radius of convergence?
1.
Very good. That's it. The radius of convergence is 1. The interval of convergence is from -1 to 1. And that is what power series lets you do. So power series lets you do what? Sorry. So I'm going to define what a power series is first, and then I'm going to start writing the comments. So what are power series? And here is the thing coming up. So our power series is of two forms, is of the form. And don't worry about it so much. X to the n goes from 0 to infinity. If you don't like this one, always write it out. We have always been writing it out. So I want to see what this is. So I'm going to say this is C0 x to the 0, because that's n equals 0. C1 x to the 1, C2 x squared. You should be wondering, what are these C's? Oh, they are just constants. And C's are also called the coefficients of the series. Oh, we have seen this. When I've seen this, what am I reminded of? If I write this as 1 plus 2x plus 3x plus 4x squared, this is a polynomial, isn't it? I've seen this. I know these numbers are called coefficients. So you are just writing it in a different way, but I've never added a polynomial that's infinitely long. That's the whole difference. So I have worked with polynomials, not infinitely long polynomials. That's all. But this is all the same thing. So the other idea is what is a power series that is centered at A. And here is the other one. So if you have n equals 0 to infinity, Cn, x minus a to the n, which is C, x minus a to the 0 plus C1 x minus a to the 1 plus C2 x minus a squared plus C3 x minus a cubed. I should get rid of the dots there. And now the dots. So this is called a power series, which is centered at A. But I want to point out to you that this series that you're saying centered at 0 is really a polynomial that looks like this. What about this one, which is centered at some A? Well, I can say this is if you want, throw in some numbers there, 11, 7, 9, 5, whatever you want. So again, these are the coefficients. And this is centered at what? So tell me this will be centered at what? But in other words, I'm saying, oh, this is a polynomial again. Because if I sort of expand this one, this is going to be some sort of polynomial. It's just we are adding infinitely many terms. I want you to fill in these blanks. This would be centered at what?
-2.
Look at the definition. So let's make it centered at -2. Will be centered at this. And what about this one? Look at the model, Russell. We are saying,
Okay, yeah,
yeah.
I see it.
So this will be centered at 2. And because you mentioned -2, here is your centered at -2. Why? Because I claim this could be written as x minus -2 to the n. And then you can look, instead of a, you have -2.
Quick question though.
Sure.
Going back to the original sigma CNXN,
Mhm.
you have the coefficients starting at 1. Wouldn't it start at 0?
No, the coefficient is, this is, see, x to the 0 is always going to be 1.
Right.
And so I just made a number for c sub 0, which I put to be 1. It doesn't have to be 1, it could have been 11.
Ah,
Which is, yeah.
that's what
But
I was
it is,
confused about.
now it is 11 plus 2x. What I was trying to say was these constants are just constants. They are coefficients. They are just coefficients of the powers of x. That is what they're saying. So in some ways, I'm going to say that, oh, you're not telling me anything new. This is just a polynomial. It's just an infinitely long polynomial. The conceptual part of it, which is this infinite sum, is different. But have I seen polynomials before? Absolutely, yes.
Got it.
And then we are talking about these, which are again polynomials, but now you're presenting them to me in a different way, which is centered at a and centered at 0, those kind of polynomials. So I want to go back and say to you to this one. So what about this one? So this is centered at what? So this is a power series.
Well, didn't you already write it's centered at 0?
Very good. So this is centered at 0, meaning you are now going to, you're absolutely right, but I wanted to kind of fuse everything together because I did this to explain you the radius and the interval of convergence. And now I'm going to say this. So far, you have been dealing with series without a variable. Meaning what? Oh, you have dealt with n factorial, I'm just making something up, and 2n plus 1 or something like that, not factorial again. So 2n plus 1. And n was from maybe 1 to infinity. So you have dealt with series like that. You have dealt with 2n over 3 to the n goes from 1 to infinity. You've never dealt with x, but now you're going to deal with power series. I'm repeating myself, which are going to look like what? Cn x to the n or Cn x minus a to the n. So what do you want to find? We want to find the values of x for which this series converges. We use the newly discovered fact that, if you have absolute convergence, then the series converges. We also have this ratio test. So here is the question. So here is a power series. I want to put it in a box. So first you have a power series. You want to find the values for x for which it converges. So what are we going to use? We're going to use this fact, but for absolute convergence, you use the ratio test. So after you use the ratio test, you're going to find two things: the radius of convergence, which I like to do in pictures anyways, and the interval of convergence. To find this interval of convergence, you might need to use your previous test. So previous tests are useful now, are used here. I think at this point, I should do an example and make sure every little thing I say is taken care of then. So let me take a very, very nice and simple example to begin with. So here it is. Or maybe you are ready for some.
No,
Why
let's
not?
let's go with simple.
You're ready for this one. I think you are. If not, we will go for another simple one. So here it goes. N equals 1 to infinity. 10 to the n. X to the n over n cubed. Number one, we will write it out. I am not going to let you bypass that. Ten cubed, x cubed, 3 cubed. So agree with me, this is a polynomial, right? Right, people?
Yes.
So centered at what then? Very good, Karen. It's centered at 0. So far, so good. So what do we want to find out? Exactly these x's, these are your unknowns. We want to find out for what x does this series converge. Do I want to find out the sum? No, because you would notice it's not a geometric series. Right now, I'm just going to answer this question. So in other words, I want to know the radius of convergence and the interval of convergence. So I'm ready for that. It's already centered at 0. So let's start. So what do we use to answer this question? We use the ratio test, which goes what? Oh, it is limit as n approaches infinity. I'm going to write something. You are going to tell me if this is, and you are going to tell me if I should pause, you have a question, or you are with me. So give me some indication, people. Lucas, Sam, Aaron, that you're with me. You can click yes there. If you want me to pause, just say that pause, please stop, or something like that. Okay, Nara, so I'm going to wait for you to stop writing or finish writing and be with me. So Trent's question, can somebody answer that one? So he says, how did we get it centered at 0? So that means everybody has that question. Trent, for you, I'm just going to say, look at the definition of power series. So what did we say? Let's look at this one. If you have something like that, then it is centered at A. So I'm going to come back to our example and say, can I write this as x minus 0 to the n? Is x to the n the same as writing this as x minus 0 to the n? Yeah. And so up here, when Russell was talking about this one, we did this, which is centered at 2. We did this, which is centered at -2. So if I want to connect the two concepts, Trent, I'm just going to say, always remember the equation of the circle. If I gave you x plus 3 squared plus y minus 2 squared equals 9, then you would say the center is at -3 and 2. That's it. That's the center. So go by that one, if that helps you. Otherwise, if it confuses you, throw it away and say, no, this is not helping me. Okay, so here we are. So I'm going to go work very carefully, which is I'm going to collect all the terms together. You can work whichever way you like. So here we go. And I'm going to say this is 10 to the n plus 1, 10 to the n, x to the n plus 1, x to the n cubed over n plus 1 cubed. So I'm going to write this as, I'm going to just simplify. So here I collect all the terms together, all like ones together. The next time I simplify, and I have 10 to the n x times n over n plus 1, I think I can safely write this as cubed. I'm just going to remind you, limit of product is product of limits. And yes, I have made a mistake, and it's intentional, so time to catch it.
Put a little pressure there.
Yes, so what is the mistake? And the mistake is in the line after simplify. So what is the mistake? There we go, Tiffany. It is 10 and not 10 to the m. And Karan, you too. So thank you for catching that. So if limit of product is product of limits, this is what I meant to write. This is limit of product is product of limits. I think I'm going to write it carefully. Is product of limits. So I'm just going to talk to myself now. N approaches infinity, the limit of 10 is just 10. Limit as n approaches infinity of x is just x, but it's absolute value. Why don't I write absolute value here? Because absolute value of 10 is still 10. And what about the limit of this one as n approaches infinity? What about this limit? And that one would be?
1.
Very good. So what does the ratio test say? So the ratio test says, because this is your limit, see, this is your L. So ratio test says if L is less than 1, the series converges. Okay. So that means it is saying that 10 times absolute value of x is less than 1, then the series converges. That means we are saying absolute value of x is less than 1/10. That is where I start drawing my pictures. You said the center was at 0. Absolute value of x is less than 10 algebraically means -1/10 is less than x is less than 1/10. So here is -1/10. Here is 1/10. So you are saying, what is the ratio test saying? And at this point, I want everybody to stop writing. It's saying in between it converges. But then it tells you something else. It says this, and it says if L is greater than 1, it diverges. Which means what? Absolute value of x greater than 1/10, it diverges. But if absolute value of x is greater than 1/10, then I know algebraically it means x is greater than 1/10 and x is less than -1/10. And this is the picture I like to draw. So I'm saying, oh, here it diverges. Here it diverges. So tell me on this number line, what are the points where I do not know what happens to this series? For what values of x, I do not know what happens to this series, which is what? So let me run that by you. Very good. Thank you, Karan. So in between, if I pick any number, x to be anything in between, what do I know? It converges. What about outside? Oh, I know it diverges. What are the two places I do not know? Why is that? Because look at what you said, and I'm going to circle these two inequalities. You said x should be between, it converges. You said if x is greater than, it converges. We just do not know the ends. So I'm going to say, check the ends. Ends of what? Oh, ends of that little pictorial we have going on here. So I'm going to remind you what the series was. Oh, the series was summation 10 to the n, x to the n over n cubed. So we know what happens for all other values of x except these two. So I like to divide the page. And I'm going to say x equals 1/10 here. And I'm going to put x equals -1/10 here in the series. I want to pause a little bit. Is everybody okay? So again, maybe I should ask this and then open it up to questions. So here's the center is at 0, isn't it? So can you tell me what is the radius?
1/10.
There we go, sir. And what do I just want to know? I want to know the interval because I don't know about the ends. I don't know if this is in the convergent group or divergent group. If -1/10 belongs to the red arrow or it belongs to the converges part. So I'm going to plug in. So plug x equals 10 in the series because that's the value you're checking for. Why? Because those are the values you are checking for. You know what happens to all other values except these two. So if x equals 1/10, what does the series become? Oh, it becomes 10 to the n, 1/10 to the n over n cubed. So what does this series become then? And this is n equals 1 to infinity.
I'm tempted to say it's a Riemann sum.
It's not a Riemann sum because Riemann sum is something totally different. When you take the Riemann sum, it is a sum of a quantity, like the area of a triangle and so on and so forth. But we did the surface area of the cone. So Riemann sum was to set up a definite integral. We are not talking about definite integral here, meaning, in other words, you haven't chopped anything into pieces or nothing like that. So I'm going to go with Karan's answer, and this is 1/n cubed, isn't it? All right, people? Because 1/10 to the n will be what? 1 to the n over 10 to the n. The 10 to the n cancels, and you get 1/n cubed. And talk to me. Do you know about this series, converges or diverges? Very good, Trent. So this is a P series. I recognize that. It converges. So what happens when you put x equals 1/10? Oh, the series converges. So mark this one, sorry. So mark this one, x equals 1/10, you got convergence. Now come here and do the same thing. So now you're saying summation n equals 1 to infinity, 10 to the n, -1/10 to the n over n cubed. So what will this be?
-1/n cubed.
You're just missing the one part of it, -1 to the n over n cubed. Very nice, Karan. So this becomes what? An alternating series. And we have done enough of those. So by alternating series test, by AST, what can you say? Does this converge? Very good, Trent. Why? Because your Bn is 1/n cubed. It is positive. It is decreasing. And its limit is 0. And remember, by the way, you all got the convergence test PDF that I put in, correct? And that has everything. That has this ratio test, everything in it. So I want you to use that because take the advantage of the situation. You are going to be allowed to use that. I take that back. I'm yet to hear from the department, but at least I'm going to sort of say that we should allow them this cheat sheet. So by alternating series test, what do we have here? Converges. So I'm going to go back to my pictorial, and I'm just going to say, just give me a minute before I get there, Russell.
No worries.
So I'm going to say that at -1/10, it is convergent. 1/10, it's convergent. So I'm going to write it all here. But the radius of convergence is 1/10. The interval of convergence is -1/10 to 1/10. So you are saying that series for all these values converges. What about outside? Diverges. And that is what we are finding with this ratio test. And now I'm open to questions. Russell, go on.
So on the left,
Mhm.
why is it 1 over n cubed when you also have the 1 over n on both sides?
No, you are talking about the
So
P series
when you're
or
plugging it into the series, right, you have 1 over 10
correct,
and you have negative 1 over 10.
correct,
And then you go down and you have 1 over n cubed and negative 1 over n cubed.
correct.
So on the left, we get rid of the n, but on the right, we keep the n.
Oh, that is because if I understand what you're asking, that is because I can write this as negative 1 to the n over 10 to the n.
Right. I
This
get
is all,
that.
yeah.
But on the
So
left, you can write it 1 to the n over 10 to the n.
right, and 1 to the n is always going to be 1.
Got it.
Yeah. So you're absolutely right. But this 1 to the n is always going to be 1. But negative 1 to the n, I don't know. It depends on n, right?
Right.
Yeah. And that's what Karan was trying to tell you as well. Any other questions? So Sadhna is quiet today. Cicely, Jezebel, where are my girls? And yes, Elian, before you start, yes, you can form your own group, whatever, boys to the rebel or something like that. But okay. Okay, so I'm going to pause then. So let me know that you're taking notes because I'm going to start the other one. And in all fairness, boys now. Elian, Sam, Aaron. See, you have a representative talking to me, which is Russell. So I don't have to worry about the boys. You're all after the beard. It's all recorded now. You know what I'm going to get into? I'm going to get into trouble with this technology thing, Russell, because my style is so sort of spontaneous, and I know many bad things to say, and in many bad ways, and it's all going to be there for eternity. It's going to be my downfall, seriously.
Not today, though.
Someday, somewhere, it's going to happen. All I need to meet is one student who does not appreciate this, and that's the end of it.
Yeah, ain't that the truth?
That is the truth. And I so forget that when I get into this teaching mode, I so forget that I am, this is all recorded now, so I have to refrain from the things that I would have said in the class. And then if any student would have complained, I would have said, oh, I don't remember saying that. That was my defense. But it's not going to work anymore because then Cecily or Jezebel is going to come and say, here is the recording. You did say it.
It's all on tape.
I'm going to be in trouble. So my days are numbered, people. So let's just enjoy while we can. Say, no questions there from none of you?
I already asked mine.
That's so true. I'm thinking one of you fellows is upset there and just not saying anything. Okay. One more example. I think we need to do one more. Okay. So let's start. And at some point, we want to look into what happens, what kind of radius and interval of convergence we might get. So here, I want to point out to you that you got an interval. So here is my example 2, and I'm going to teach my example. So here is example 2. This one is going to be summation n equals 0 to infinity, n factorial x to the n. Again, we are going to write it out, which is 0 factorial. 0 factorial is 1, by the way. So x to the 0 plus 1 factorial x to the 1 plus 2 factorial x to the 3, and so on and so forth. So I know this is a polynomial because 0 factorial is 1, so this is 1 plus x plus 2 factorial is 2, 2x cubed, 3 factorial is 6, so 6 This should be a squared. So 6x cubed. I know who I haven't heard today. Amir. I haven't heard anything from you. So this is the one that we are talking about. First question. Is this a power series? Yes, because how do we know a power series? Polynomial. If it's a polynomial, it's a power series. If it's a power series, this is centered at... Fill in the blanks, people. This
0.
What? Very good. And what are we answering? We are answering for what x does this converge? To answer that, what do we use? We use the ratio test. We use the entire ratio test because we are answering this question for what it converges. And so we get to find what? R, which is the radius of convergence. I like to draw my pictures. And I, which is the interval of convergence. But when I want to find the interval, I will always remember to check the ends. This is when you need all of the previous tests that you have learned. So let's start. So I'm going to use the ratio test. So this time it's going to be pretty easy because it's just going to be n plus 1 factorial x to the n plus 1 over n factorial x to the n. So that's going to be limit as n approaches infinity. And can I say, and then you ask me any questions you have? I'll be okay there. So I'm just going to say this from here to here. I did the simplify. After this, I'm always going to use limit of product, product of limits. Please do not lose the absolute values because ratio test is to test absolute convergence. So do not save the pencil, the tree, whatever it is that you want to save by not putting the absolute values. So this is going to be n approaches infinity of n plus 1 times absolute value of x. So tell me, what is this limit? Because this is already computed limit. Limit of this one x is just absolute value of x. So we are done. I'm asking about this limit. So what is this limit?
Infinity.
Very good. So in other words, remember, ratio test tells you what? That this limit L, when it is less than 1, it converges. So this one, and I want everybody to stop writing now. As n approaches infinity, this number is growing larger and larger and larger and larger. So can you tell me one value of x? If I put in there, this limit is going to be less than 1. Who is that going to be? There you go, Karan. So if I put x equals 0, then it doesn't matter what large number you have here. That number multiplied by 0 is going to be less than 1. It's just going to be 0. You have to understand that this is already the limit of this one is already this. We've already computed the limit. We're not talking about the limit here. So I'm saying if x equals 0, then the limit L will be 0, which is less than 1. For all other values of x, this limit will be infinity, which is greater than 1. It diverges. Meaning what? I'm going to start drawing my picture. So this was the center. It was at 0. So what are you saying? It only converges here. What about here? Here. It diverges because you said for all other values of x, it's greater than 1, so it diverges. So my question to you, what is the radius of convergence? And what is the interval of convergence?
The interval would be 0 to 0.
Which means what? There's just one single point, isn't it? There's no interval. There's just one single value. So notice that there is no interval. I just use the set notation. Because you're right. When you say 0 to 0, what does it mean? It's just 0. What about the radius of convergence? because you know this is the center. You just wrote it up at the top. So the radius then is going to be 0 as well. And I want to kind of box this as well. So no questions here, which means I just want to do one more, and that will get the point home. So here's example 3. And the series looks something like negative 1 to the n, x to the 2n, over 2 to the 2n, n factorial squared. And this is from n equals 0 to infinity. So since I'm just looking at the time, let's just start with the ratio test. Remember, we are answering still the same question: for what x does this series converge? And so I'm going to start limit as n approaches infinity. This will be negative 1 to the n plus 1, 2 to the 2n plus 2, sorry, x to the 2n plus 2, over 2 to the 2n plus 2, n plus 1 factorial squared, times, and I'm going to erase this because I didn't think I would need that much space, and we have 2 to the 2n, n factorial squared, over negative 1 to the n, x to the 2n. So this is going to be limit as n approaches infinity. I like to gather things together. So it's negative 1 to the n plus 1, negative 1 to the n, x to the 2n plus 2, x to the 2n, 2 to the 2n, 2 to the 2n plus 2. I'm going to say n factorial square is n factorial times n factorial, and this is n plus 1 factorial times n plus 1 factorial. And of course, the absolute value. And so this is going to be, on the right, you're going to tell me if there's something wrong with this. And this is going to be I'll be okay there.
I don't know. The way you said that makes me think there's something wrong in there.
No, it
Okay.
is not. Just kind of get there. But yeah, you're absolutely right. Current's fine. So I'm going to pause if you're writing for a minute and let me know.
You're just determined to go past class timing. I think you do it every time just on purpose. You're like, I'm going to get an extra few minutes.
Yes, guilty of that. Because I waste that time in between talking nonsense. But this time,
Fair exchange.
So we are just going to say limit of this one is going to be the same. Limit of this one is just going to be x squared. Limit of this one is just a quarter. So I'm just going to say this is 1 times x squared because it's just a square times a quarter. What about the limit of this one?
It's going to be 0.
Very good, 0. So this limit, when you multiply these 4 numbers, you're going to get what? 0, right? For any values of x, for every value of x, doesn't matter what value of x you put in there, will this number, will this product, will it be 0?
Yes.
And the answer is yes. So the limit is 0 always. So you are going to say the limit L equals 0 always for all values of x. And 0 is less than 1. So you were saying what? Oh, by ratio test. You're saying the series converges for all values of x. What does that mean? This was a series that was centered at 0. So if I have to draw my picture, here it is, centered at 0. You're saying what? All values of x, for all x it converges. So it's from what? Negative infinity to infinity? So tell me, the radius is what? And what is the interval?
The radius is infinity,
Very good, sir.
and the interval is negative infinity to infinity.
Very nice. So I'm just going to end with this. So what kind of answers am I expecting in this section? Oh, the radius could be 0, which means series converges only at the center. Radius could be infinity, which means series converges for all values of x. Or radius is a finite number, which means the series converges in an interval. Because if the radius is some finite number, say 3, then that's the distance you're going away from the center, whatever the center may be, isn't it? And at this point, you want to check the ends. So you will see some homework today. And next time, I'm going to do a series with center not at 0. So we will practice this, and then we are going into the good stuff.
Alrighty.
So, Russell, on that point, do I make you late for your next class? Should I stop?
No, it's fine.
Is that okay? Okay. No, I just wanted to ask. If it is that, then I wouldn't go over.
I do have one quick question, kind of unrelated to the current
Sure.
bit, which is I got asked the other day by a friend who's taken calculus about a Riemann sum. I wanted to run it by you.
Okay.
So if the Riemann sum is sigma k equal to 0 to 3
Mhm.
of f of x of k plus 1, that's a right Riemann sum, right?
So k equals 0 to 3 of f of
X of k plus 1.
yes.
Yeah, that's because